Hello everyone, my name is Peijie. I'm from Hefei University of Technology. I'm very glad to share our work with you online. Our topic is about explainable recommendation. And I will introduce our work from following 5 aspects. As we know, reviews are very common in e-commerce platforms and reviews are usually used in recommender systems. For example, reviews can be used to improve the accuracy of recommendation, and the reviews can also be used to learn an encode-decode model, which can be used to generate explainable reviews. It's easy to find the two tasks are in new forms. We aim to design a joint model from a new perspective. From the multitask joint model, we know that user embeddings and item embeddings are shared among the preference prediction and the review generation tasks. In this table, we further study joint model problem. Instead of simply correlating the two tasks with shared parameters, we argue that the two tasks are presented in new forms and have intrinsic probabilistic connections between them. And we have two changes. First, how to post the duty form of the two tasks in the modeling process. And second is in the test stage. For each candidate used item pair, do not have either the preference information or the review data. How to make recommendations in the test stage when the input data are not available. As for our contribution, we first proposed a model named UPC in review-based recommender systems to inject the probabilistic duty of the two tasks in the training stage, with each probabilistic function well designed. We propose a transfer learning-based model to simulate the review representation of each user item pair to tackle the available preference and review in the test stage. As for related work, existing solutions for explainable recommendation can be categorized into 3 groups. First is reviews are used to extract key information, which plays an important role in predicting users' preferences. And second, research about the advances in natural language generation to generate reviews for explainable recommendation. Such models usually based on the encode-decode model, and for the decode model, usually based on sequence-to-sequence model. As for the joint model, they jointly learn user preferences and generate reviews with a multitask learning framework. And users and items embeddings are often shared among the review generation task and the rating prediction task. As for our purpose model, we will first introduce the overall framework of our purpose model DPC. Then we will introduce the components of our model in detail. Given a training record X, we have user A, item I, under the preference from user A to I, and the C means the review from A to I. We want to find a function f which aims to maximize the conditional probability of real preference given real context. As for the review generation task, we aim to find a function g which aims to maximize the conditional probability of real context when given real preference information. By many standard learning tasks, the preference prediction model F is learned by minimizing the empirical risk between predicted preference and the training data as this equation. And the review context generation model G is similarly learned by this equation. In fact, as shown in this picture, the two tasks are presented in dual forms. Therefore, we associate the two tasks with dual learning. We treat the preference prediction task as the primary task and the revealed content generation as a dual task. If the learned primer and the dual models are perfect, the probabilistic duty between them should better satisfy this function. By combining the probability correlation between the two tasks and the empirical losses of the two tasks, we should have this optimization function as directly putting these probabilistic constraints into the two objects is not easy. We convert this one to the regularization term, and the probabilistic correlation of the two tasks are modeled by them together with weighted combination between the orange loss function and the duty-based regularization term, where lambda1 and lambda2 are the weights of the duty terms that need to be turned in practice. They control the gradient from the duty loss when optimization set and phi respectively. With larger value of them, the duty regularization terms play more important roles in correlating the two tasks with probabilistic constraints. And our model consists of three components: preference prediction model, review generation model, and the probabilistic duty constraints of DUPC. As for the preference prediction model, it can be divided into two sub-models. First is the encode part. Each inputs the reveal user information and item information, and it outputs some vector. As for the decoder model, it inputs the information, then outputs the predicted preference. And the reveal generation model also can be treated as two parts. First, the encoder model inputs user information, item information, and the preference information. As for the decoder model, it's based on the sequence-to-sequence model, and it can generate explainable text. As for the probabilistic duty constraint, we have to fill in the four parts. As for the conditional probability, we can calculate them from the above two models. As for the marginal probability of the real preference and the real reveal, we can utilize the PMF model and the second-to-second model. And here is the algorithm of our model. If you are interested in this part, you can refer to our paper. Yeah, thanks. And as we mentioned before, we don't have any reviews and preference in the test stage. So we have to think some method to solve this problem. At first, we will replace the input review C of preference prediction model with users and items historical reviews. And second, we will replace the input preference R of review generation model with predicted preference. In this section, we aim to solve the first question. The first section, yeah. As we mentioned before, we replace the review C with the user and item historical reviews. We think users and item reviews can be used to infer the information we stored in this one. And we utilize the transnet model to help us learn a mapping function, which can learn the approximated representation to approximate this result. And this is the training algorithm of the transnet part. Yeah, this is the two questions about how to get the preference and how to get the reviews. We in the test stage we replace the review with these embeddings. This means the representation of the CAR, and this means the approximated representation of CAI. And we will get the predicted preference, and we will import the predicted preference to the review generation model, and we can get the generated reviews. Following, we will introduce experimental results. I will lecture our proposed model on two datasets, Amazon Books and Amazon Electronics. And in the data preprocessing stage, we select 85. In the preprocessing stage, in order to reduce the impact on complex symbols on language modeling, we keep the reviews that only contain symbols of the comma and the period. And we select 85% of data for training, 5% for validation, and the remaining for test data. As for the rating prediction task, we use the RMC as the matrix, and we use the BLEU and the LG as a matrix for review generation. And the baselines can be divided into three groups. First is about some matrix factorization models which model the linear interaction between users and items, and non-linear interaction between users and items for the preference prediction task. As for the second group, is also for the preference prediction task. However, these models will import the review information and output the predicted preference. As for the third group, they all be used to generate reviews. And we aim to answer two questions. First is, does our proposed model UPC outperforms the baselines? And second is either proposed probabilistic duty helpful? About the first question, in the preference prediction task from this table, we can find our proposed model UPC outperforms the baselines. And for the review generation task, from this table, we also can find our proposed model outperforms the baselines in F1 and the BLEU matrix. And following, we will list some examples generated by our purpose model. From this table, we can find the reveals generated by our DPC framework looks closer to the real reveals and are more persuasive than the baseline models. In order to answer this second question, we designed an ablation study. And from this table, we can find the different settings of lambda 1 and lambda 2 will bring different results. And from this figure, we think it can prove the effectiveness of the probabilistic duality. So, we proposed the DPC to model the probabilistic correlation among the preference prediction task and the review generation task. And we designed a transfer learning-based model in the test stage to solve the unavailable preference and the review problem. And we designed and the intensive experiments onto real-world datasets shows the effectiveness of our purpose model for preference prediction and review generation tasks. So my report is over. If you have any questions, please feel free to ask me. Thank you.